Hello, good morning, or good afternoon, good evening to everyone, based on the region you are currently on. So we know that many of us are joining from different corner of the world. So I'm Kanak. So I'm with PIO since last 3 years, and I have overall 10 years of experience in IBM. So that is a brief introduction about myself. So today we'll be discussing about database and file system in IBM. So let's get started. So in today's session, we'll be discussing about these topics: DB2 for IBM overview and database files overview, where we will know about all kind of database files in IBM. We'll learn about source physical file. There we'll discuss about the creation and operations we can perform using source physical file. We'll learn about physical file. We'll see some attributes, and also we'll learn some examples. And if time permits, we'll talk about logical files as well. If not, then we'll discuss this on next session. So DB2 for IBM. DB2 is a database system, or you can say it is a set of relational database products built and offered by IBM. So it supports multiple platforms like mainframe or Linux or like IBM Cloud and also IBM I. So in case of IBM I, we call it DB2 for I or DB2 for IBM I. So this is a database manager which is fully integrated on the IBM I operating system. So as it is fully integrated on the IBM I operating system, so it is highly secure and easy to use and manage. So basically it manages the database files, and it provides two kind of access methods for manipulating database tables or database files and data. One is SQL, another one is system file access methods. So let's move to the next slide. Database files. So as we mentioned, like DB2 for I, it manages the database files. So what is a database file? Database file is nothing but a file that contains data. So here we mentioned like database file is a system object of object type asterisk file or star file. So why do we mention that? Because we know that in IBM system, the system treats everything as an object. So be it a library or anything. Here we are talking about database files. So the system will consider everything as an object. So whatever operations we are performing with any kind of system resources, those are will be called as object. So how here database file is also an object of object type star file. Consider this table that is displayed on the screen. This shows that ordered item, order count, and price. Suppose a customer, they placed an order in any platform like e-commerce platform or anywhere in a shop. This is the data. So this data, when it is stored in our system, we call it a database file. System considers it as a database file. So the actual data is stored inside the storage media, and our system, it considers is, or it contains a description of how the data is stored in the system. Or later we'll know that how the data will be manipulated, or like how can we retrieve the data, that will be handled also. So this database file contains the description of that data. There are mainly three types of files we'll talk about: source physical file, and logical file. So let us move on to the source physical file. So as we mentioned that all the database files in the IBM system will be of object type star file. So the source physical file is also an object of object type star file. And what it contains, the source physical file contains the source members of different type of objects. As we mentioned in the IBM system, there are different types of objects. For example, some can be database files, some can be programs. We'll learn about program later, but that manipulates the database files, and some can be libraries and so on. So to create certain kind of objects, we need source members. So the source physical file, it contains the source, and we usually use crtsrcpf command to create a source physical file. So let me show you some example. So here you can see that this PIO int sources I have mentioned here inside library. Inside a library, there is source physical files, different source physical files. So these source physical files contains like the source of different kind of objects. So we can see the same on the green screen as well. As you mentioned that crtsrcpf that is used to create a source physical file. So let me log into the system. So we mentioned that crtsrcpf. So this command, this is a CL command we are running on the command prompt. We can run the same here as well on the VS Code session here. So the same thing is running, I'm running on the green screen. So here almost all the commands, CL commands are self-explanatory, like CRT for create, SRC, source, PF, physical file. So every time we are running a command, we can take F4. That will show us that we are creating a source physical file. So these are the keywords or parameters we need to mention here to create a source physical file. So suppose I'm giving any name here, test src pf. Okay, pf1 suppose. So I'm creating this source physical file. I need to pass this parameter. I need to give one library name. As we know, library is a system object of object type star file, star lib. And here inside this library, I'm creating one source physical file. And this is the record length. Here by default, it is taking 92, but we can change it. Okay, so let's suppose I am giving any length. Suppose I'm giving 10 here, for example. And here I'm giving text. You can leave the member parameter blank or star none. So here test description, we can give some meaningful description to this. Suppose test source pf. When you press enter, you can see here that the record length parameter must be at least 13 bytes. So it has to be greater than 13, but by default it is 92. So let's take 92 or any number more than 13. So this is created. Test src pf1 is created in PIO int. So let's go to the source physical file. So this is the source physical file which will contain different type of sources. We can put different type of sources here. So for example, the previous example we were saying, like this was also a source physical file. And if we navigate here, we can see that it contains different type of, we mentioned object type, right? So different type of sources is present here. And we mentioned the length, right? So if we check this to browse any source here, we usually take 5 option. Okay. or here also we can browse any source. This is source physical file, and here also you can browse any source here. Suppose this one. So it will open it. And this is nothing but a source member, which will be compiled later to create an object. So as we mentioned some length there. So here you can see the source physical file. It contains three parts mainly. One is like sequence number. This is nothing but the line number of the source. It is sequential. And one part is like date of the source. If I change any date here, if I modify anything inside the source, that this date will be changed. This is date part, and the in between this part is source. So we can store source here. Why do we usually mention 92 or greater than that? Because everything inside the source physical file, especially when creating a database file, there are some like fixed lengths as it is mentioned here. So everything needs to be put in that order, in that particular position, to make the source get compiled. Okay, so here is the date part, here is the sequence part, here is the source part. Let's move to the slide now. Yep. So as we explained in the VS Code session and on the green screen, that source members of various types are created in the source file. You can see now that there are various types of sources that are present in the source physical file. And next point we are mentioned that source member is compiled to create an object of specific type. So once we create the source, we'll compile that source. Once we compile it, it will create an object, and that object will be used for various purposes inside our system. And this is also covered like source sequence, source date, and source data. We'll move to the next slide. It is physical file. So physical file, when you say physical file, it physically contains the data. Okay, it is also of object type star file, and this PF, we call it in abbreviation PF. So this PF contains description of how the data is stored in the database. Database will store the data or on specific record. For example, the database for the table I showed in previous slide, the order item, order count, and price, that will be stored in the database system in a specific structure. So APF contains that description. Okay, so it will contain one record format, one or more members. We'll explain this later with example. What is record format or what is member? And the structure of the data that can be specified in a source member is a source in a source physical file. Okay, so this structure is called data description specification, DDS. So to create a database file, we need a DDS. There is another way also to create a database file, that is DDL, that is SQL table. And through that also we can create a PF. But here in this session, we'll discuss about data description specification, that is DDS. So we need a DDS to create one physical file. And this is the command, example command to create one physical file, crtpf. As I mentioned earlier that all the commands are self-explanatory. So crtpf create pf or create physical file. These are the parameters like what physical file I am creating and what source physical file I am referring to. This is the library name. This is the object I am creating, that is pf object. And this is the source physical file. This is the source where the source physical file resides, and what is the source member I am compiling. So when we compile a source, this is the command that runs in the background. We'll see the example. Okay. So to get to know about the PF more, we can consider this one. So many of us who joined in this session, you know about the SQL. Maybe in your academics, you have heard about the SQL. Suppose this is one SQL table, or consider a table, only table. So in SQL, what we call it table, but inside IBM system, we call it a physical file. Okay, so this one we'll call physical file. In SQL, what do we call this one? We call this row. So these are the rows. There will be multiple rows of same type, like ordered item, order count, order price. These are separate rows in a table. In our IBM system, we call it record. Okay, so row is equivalent to record here. And in SQL, what we call this? We call it column. So these are the different columns which contains the record. So in our IBM system, we call it field. So in short, a physical file, it is set of records. These are the records. So it is a set of records, and record is set of fields. This is one single record because the database file will consider this as a single record, and the structure is like this. So these are the separate fields. And when we mention library, like the physical file or source physical file, these are inside a library. So that library we call in SQL schema. We can compare like that. So inside a schema, there is a table. That table contains multiple columns, and it contains the data in separate rows. So here inside a library, we have one physical file that contains data, or you can say that contains records, and that record is divided in separate fields. Okay, now we'll learn about how to create one physical file. We saw the command, but how to create it using DDS. So we need to tell the system that how they will store the data. So once we put the data, we need to tell the system, yes, you need to put it in a specific order or a specific structure. Like this can be alphanumeric, the count, order count, it should be numeric, or price. It cannot be alphanumeric value or character value. The price needs to be numeric. This way, we need to tell the system that you need to store the data or process the data in this structure. So for that, we create DDS. We call it data description specification. So to define a physical file, we need to create one DDS. So these are the steps, like we need to create one record format, specify one record format, and by defining a new record format or by sharing existing record format. We'll discuss this in the practical session now. And there are some levels of the DDS: file level, record level, field level, key field level. So let us consider the same table of orders, that is this one, and we'll see how we tell the system to process this data in this specific structure. So in this example, this is one DDS, simple DDS of the specific table. So we are naming it order PF, and here this is the record format. So we are naming it order PFR. We need to give one specific name here. So we are giving a name of order PFR. And these are the fields: item. There we mentioned pen, pencil, notebook, like that. So this item, this will store the data of that specific item. And order count, we are mentioning it order count, and price. So this part 10A, 5S0, 5S2, these are nothing but the data types and the length of the field. So we need to tell the system how much length you need to allocate for that specific field, that is item or count or price. Same we can see on the green screen as well, this one. So this is the field item, and this is the 10 length of item with the alphanumeric code, and count is of decimal, and this is nothing but decimal place, and 5 is to decimal places 2. That means if the price is 400.50 like that, so decimal places 2. So here on the slide we mentioned that file level, record level, field level, and key field level. Here only we mentioned only two levels, that is record level and field level. These are mandatory, and other two, file level and key field level, those are non mandatory. I'll show you example. Suppose this one. Okay, here we mentioned something, we call it file level entry. This is record level entry. Record level is nothing but the record format. This one we call is a record format. It contains the format of the data, this format of the data, how it will be stored. And the field level, it tells the program how the field will be structured. So this one is a student table, so roll number, first name, last name, gender, DOB, address, phone. All these fields are there inside this record format, STUDFR. And here also we have put the key field as blank. We'll explain it later. So once this structure is provided to the system, if we compile this one, it will create one object of name, whatever name we will specify, and the object will follow this structure and it will be stored in the system. So the next step is like to create one object out of this. Okay, so let's take example of order PF. To create one object, we mentioned that CRT is used, and it is nothing but compiling the object. If you take 14 here, that will compile the object, and here in VS Code you can take Control E, and that will mention create physical file. Both does the same thing. So behind the scene, if you take F4 here, it runs the CRTPF command to compile the object. So there we mentioned that these parameters we need to provide file. So we have created the source with order PF name. Here we can give any other name to create the file. And this is a library, in which library we are creating the file. And as we have taken 14 option across the source, so it is referring this source in this library and this source member. Let us check it again. So this is the source order PF, we call it source member. Physical file is here, it is mentioned file. This is physical file which contains different sources, QKNAKSRC. This is the physical file. This is the library. Inside this library, this physical file is present. Inside that physical file, sources are there. When you compile this, whatever parameter we will pass here, that will be created. If we give a different name, the object will be created with that name. And this is a library where we want to put that object. That is the library. And it is referring to this source library and order PF. So once we hit the enter, you can see order PF created in library PIOINT. Okay. So we can check this object that is created. There is a command work object, and we can mention that it was written here that file order PF created. So we can take always F4 here, we put the object here. We can give the library or we can give star libl. Okay. If we hit enter with star libl, we'll see that it has taken the object from the list we have mentioned here, the library list. From here, it is referring. So the file resides in PIOINT library, that is order PF. So our PF is created with that specific structure. All right. So let's move to the slide. So we mentioned the file record level and key field level entries. There are multiple file level, record level, field level, key field level entries. We'll see some of the examples of this. And for the different keywords and will run in the system. Okay, so there is a keyword. First keyword is file level. So let's learn about file level keyword. Inside my source physical file, I have created this one, student S. Okay, so here we can see only record level and field level is mentioned, no file level is there. Okay, so we can mention the optional parameter file level for some specific task. Okay, and key field level we can mention here for some specific task as well. Okay, so let's compile this physical file as well to create one object. The object is created, and if you want to create again using CRTPF without compiling it, or if you want to compile it using 14 option, you can see that it will ask that the object already resides inside my system. So we need to replace the existing object. If we press no here, it will not create the object again. Okay, we can delete it. If we replace it, it will be replaced. And another command I mentioned, CRTPF, we take it and you put manually everything that I want to create this object, PIOINT, and I'm referring this PIOINT. So it will show that it already exists. So we can delete the object and we can compile it again, or you can replace the object. So we mentioned that file level and key level. So to understand this, let us take more example. Okay, these are some example of the DDS, how it is created. So same, we showed that file level and field level entries. This is file level entry, field level entry. Okay, so here we can see in the image that we have mentioned unique here. So this source specifically tells the system that you need to process the data in a certain manner that it will consider the data as unique. So for this, file level unique. So and key field level roll number. So to understand this, let us take one example. Okay, this one is the data which contains roll number, first name, last name, gender, date of birth, address, and contact number. All right. So we know that in a class, roll numbers are not same. Not two student will not have the same roll number. Okay, and in that case, it will be like duplicate. So that is not possible. So to tell the system that this roll number is unique, we mention the file level keyword unique, and in the key field level we mention the roll number. So roll number is the key of that physical file, which is unique value. Okay, to understand this, we'll run one example later. Okay, next topic is like data types of the physical file. So data types is nothing but what is the type of the data. As you mentioned, this is the decimal, this is alphanumeric, and this is alphanumeric, this is decimal. So there are different types of data types, like P denotes the packed decimal type, S zone decimal, and we can see here zone decimal, and this is the decimal places, and all other types are there. If we don't mention anything here at the point of this data type, the system will consider this as, if I put 6 here and space 0, so in that case the system will consider this as packed type data, that is numeric data. And if we do not mention anything here, the system will consider this as alphanumeric data. Okay, and there are different types, and here we mentioned that a character if the decimal position 36 to 37 are blank, so it is mentioned about this position. So you can see this is 30, this is 35, and this one is 36. So this position, if we don't mention anything here, the system will consider this as packed data. And if we don't mention anything here, the system will consider this as alphanumeric data. Okay, these are the different data types. And one thing to know about this one is we mentioned that file level, record level, field level, key field level. So if you want to compile this one, it will compile. But if the structure needs to be followed, it needs to follow the same sequence. If we rearrange the sequence, if we mention this key field level here before the record level, it will not create one object. We can see one example. Suppose this student so this one, if we mention this unique, this file level keyword, if we delete it from here and if we place it here after K, okay, and if we try to compile this one using 14 option, it shows that errors in DDS. So it will not allow you to compile this one. So let us put this here. Okay. Yeah. Next topic is like, once the object is created, how will you write data to that object? Or we have created the order file, how we'll enter data to that? So these are the ways we can enter data: update data, run query, or SQL. UPDDTA is a command that can be used to insert, update, delete records in a file. So let's take an example. We have created this file, right? Order PF. So it is mentioned here UPDDTA, update data. Take F4. We can mention the database file name here. We need to mention the library, EIOINT. So it gives us an interface to insert the data. So let's insert some data here. Okay. So let's insert pen. I'm taking pen 20 count and 200. Once we hit the enter key, it will enter one data. Suppose pencil, I'm taking 10 and the price is 30, and so on. Book. And once we hit F3 and come out of this, data are written there. So with the same command also, we can see the data. You can see this was inserted here. We can update this one here. If we directly put suppose 30 and change it, it will be updated. And if you want to delete here we also we can delete it here. Okay, you need to press Shift F11 twice to delete the record. So right now only one record is there. If you want to add more record, you can take F10 here and you can add more record here. Suppose eraser of count 50 I'm taking, so 300. That is added. Next was mentioned run query. So let's see what run query does. For run query, There is the format, specific format, run query, and library name. Or we can always take F4 here if any doubt. So here we need to give the file name, order pf, library name, int. So it will run it and it will show in a tabular format that this data are added there. Okay, you can see here it has taken decimal places because it was of the structure was 5s2. So the decimal places it has taken. Let's see it again. So this price, okay, so it has decimal places, 2 decimal places, we saw that. So if we increase this, suppose 560, these last 2 places will be considered as decimal places. So the output should look like 500.60. Okay, this will be 500.00, and this will be suppose 300.30. So last 2 places are decimal places. And if we run query again, we can see this data like this. Count on this. And another way we mentioned here, that is SQL. So many of you have heard about SQL queries. So here we can start one interactive session that will allow you to run the SQL queries. So the very popular SQL query is select star from PIOINT. We need to give the library name and the file name. So all kind of SQL queries, select, query, insert, update, delete, can be run from here. So if we run this, we can see the same result. And we can run update also. And it has some added benefits like we can always take F4 everywhere. So suppose I'm giving update, I'm taking F4. It will ask for the file name. It will ask for the library name. So like that, we can give the update query. We can write insert query as well, insert into database file. That also can be done from this SQL. Okay. Next is DSP-FD and DSP-FFD. So these two are very important commands that we use in IBM system. DSP-FD, that is also self-explanatory. DSP, display, FD, field description. DSP-FFD, display file description FD, and this DSP-FFD, display file field description. Let us run this command. DSP-FD. Let's see what it does. So file is VIO, okay, order PF and PIO INT. So here we can see that it is showing all the description, everything related to that particular physical file we created on the system. File is order PF and the library is PIO INT and all other information. What kind of file is this? It contains data or not, and so on. All the information related to the file are stored here. You can explore this with this command, every parameter, that what it does and what all information it stores. Same way DSP FFD, DSP FFD, and the file name order PF, PIO INT. Here you can see the structure of that file. We created the file with 3 fields: item, count, and price. Item is of 10 length, and the count, item order count, this of 5 decimal places for 5 numeric places, and the price is 5 length and the numeric place is 2. So this shows the field length, buffer position. Okay. and we can create this one. So this for students, then say DSP that will also show us the field description of all the fields: F name, L name, gender, DOB, address, phone, and every other fields. We mentioned SQL. There also we can see this. Select star from students, and here always we can mention the library name PIOINT. You can give your forward slash or dot, anything. If we take F4 here, it allows us to see the fields. So here select fields, we have given star, so it will select all the fields. If we want to get the specific fields, we can take F4 here. So here also you can see the structure of that table or physical file. So we mentioned roll number, F name, first name, last name, gender, DOB, address, phone. The same we mentioned here in the screen. Roll number, first name, last name, gender, date of birth, address, and contact number. So these all are mentioned here. Type also mentioned here: numeric type, character type, numeric character type, like this. Here we can take F11, that will show us the text. So what is the text? So this left part, that is ROL, LNO, these are the fields, 5 fields we mentioned, that column names or file fields, the roll number, and this is the name of that field or text: roll number, first name, last name. Here on the field level keyword, we mentioned column heading, that will assign the text name. We can separately give one text also, that we mentioned here in the field level keyword text. It gives the column heading. This text will contain some additional information about that field. So in this case, we have mentioned column heading. So our system considered this column heading and it displayed it here. So whenever we run this query, if we run select, suppose I am selecting few fields, roll number, first name. Here we take one to select the fields, and address, like this. Okay, no data is there, so it is showing nothing. So the query looks like this. So let's add some data here. Let's add using insert query. Insert into PIOINT and student Fs. Okay, let's take F4. Here it is showing that do you want to insert so to single fields. So here you can give Y. So what it will do, it will insert for specific fields. Rather than doing this, let's take it as N. It will insert for all the fields. We can specify values here that will be added directly to the database. I'm giving one here, and F name, that is a alphanumeric field. So we need to give here one quote, and suppose I'm giving here, let's take the example of this Priya, Priy, and last name we can give, I think, gender, F, date of birth 20240102, sorry, 2004, and address we can give something, any address, test address, suppose, and contact number. So I'm adding this record here. Okay, it is telling. Okay, I forgot to mention the quote here. The single quote it may necessary because it's an alphanumeric field. Okay, this also need to give single quote. And one row inserted in PIOINT. You can manipulate this to add another row. So what if I insert the same row, or like some value I keep the same and I change the name here. Suppose what was the next name here? MD Amir. So I'll press here MD. I press here Amir. roll number is 2, this is M. For better understanding, we can always take F4. Okay, you can take F4 here. So here you can give DOB test address 2, and as you can see that for all the alphanumeric values I am putting in single quote. For all the numeric values I am not giving any single quote. This is the way we insert data using SQL. So this data is also inserted. So if we see the data using SQL or run query or update data anything, we can see this data. Okay. So now I'll explain about the concept of the file level keyword we mentioned previously. Suppose I'm inserting this data and I'm inserting again, or by mistake, I'm inserting the data again with roll number 2 or some different name. Suppose my name. Okay. So I'm giving something like this. So in that case, it is inserted. Okay. We can always update the record. If we want to see the record here, okay, F9 brings the previous query here. So if you want to see the data here, it shows that this data is written incorrectly, roll number. We can update this. We can always update the file and set the value as 3 or something. But if you want to suppose prevent this from updating a duplicate record, or like that the roll number should be unique, 1, 2, 3, 4, 5, like that. So we can create the DDS of the file in such a way that it will not insert same record twice. So there comes the unique concept. So here we are mentioning unique to the roll number, the key field. It is related to this one. So if we mention here K as roll number and unique, if we insert data to this one, this will not allow us to insert duplicate record. Let us compile this one. It is compiled. Let us add data to this. Okay. Let's use update data. You can use anything, update data as SQL. So here, roll number 1, I'm giving something like this, gender as M, date of birth something 2020, like this, address, any value, contact number. So you can notice one thing, that using update data, we don't need to give the quote here, but using SQL, we need to give the single quote for the alphanumeric values. You can see it. Something like this, you can put here. Okay. So I'm updating this. The roll number I have put as unique. So if I try to insert another data with the same roll number, let's see what it tells. I'm putting everything else different. For example, testing and gender F, date of birth 2020, address anything, contact number also anything. It tells that file students cannot have a duplicate key. So this way we are restricting the user to insert one duplicate record. So there comes the concept of unique keyword at the file level. Okay. This is the file level unique keyword. And this key field, this is the key field we are assigning unique to. Okay. And also the key field, if we don't mention anything here, we don't mention unique, still we can put the key field. So what is the significance of that? This key field will arrange the data. When we retrieve the data from the system, we'll learn about that later. So when we retrieve the data from the system, it will arrange the data. It will sort the data based on this key field. So roll number, it will, if you retrieve the data from the file, physical file, it will show you the data on a manner like roll number ascending order. If you don't mention anything here, it will be ascending order. So in the keyword section, we show that descend. So if you mention descend there, the data will be stored in the retrieved from the system in a descending order. It will store in the how we are adding the data, but when we retrieve the data from the system for some specific operation using program, so that time it will retrieve the data in that order. Okay. Suppose example of this DOB. We want to know that the requirement is like we want to know the date of birth, who is older. Like in that manner, we want to order the data in a descending order of date of birth. For this example, here date of birth is for Amir. Here date of birth is like this value is greater 2007 1205. So when you retrieve the data, it will first show you this whatever is the highest value, then 2006. So descending order. Okay. So there is another concept like composite key. In this case, I'm defining three key fields. Suppose, consider an example like first name. There can be students same name, multiple students, and I want to retrieve the data in a manner that if they are having same name, I want to arrange the name according to the last name. Suppose two are having same name as Priya, okay, and one is having the last name as Kumar, another one is Singh. So it will arrange in such a way that it will order it in last name manner. Like first name will be same for both. So it will first load the Priya Kumar, or again it will load the Priya Singh, that way. In case both are having the same first name and same last name, we have mentioned one another key, that is date of birth. So whoever is having the date of birth, uh, like whoever is younger, date of birth will be in ascending order. If we don't mention anything, it will consider is an ascending order. So whoever is younger, that data will be displayed first, then the another data. So this way we can arrange the data. We can assign the key fields to a physical file. We can assign that to display the retrieve the record in that particular order. Okay. So here another thing we mentioned in the DDS. Okay, we can show that in the session as well, or in the VS Code, that this TDS student PF. Okay. Example of another field level keyword. Okay, it is loading. So here you can see that we mentioned column heading. We mentioned that column heading will give the name to column. We mentioned another parameter here, values, MFO. So whenever we put these values here, the system will allow only these values, nothing else, MFO. Okay, so for example, suppose for this particular file, if I want to insert record into this file, we can take student s and mention, yeah. So if I want to insert data to this using SQL or UPDDTA, and always put the library name here, int, or else it will take from the library list. So here we saw that there we mentioned gender, specific genders. So suppose I am trying to insert a record, test, gender I am giving lowercase m. Okay. So it will show you like this, value entered in the field is not valid. Okay, so we need to give the particular value. If we give anything else, the system will not allow it to enter that data. So that is the uses of these values. So on, there are so many keywords there. For better understanding, you can maybe refer to the ebook, or you can explore on this, that what all functionalities, this field level, key field level, format level, or file level keywords touch. Okay. Before moving to the next slide, and to add few more information about this DSP-FD. So we mentioned that DSP-FD will tell us about the file information, DSP-FD and DSP-FD file fields information. So in the previous one of the previous slides, we mentioned source physical file. That is nothing but this one, source physical file. Okay. So this is also one file. So let's see whether we can implement that command on this one, DSP-FD on a source physical file. Till now we were doing it for the physical files, but now we'll do it for a source physical file. DSP-FD source physical file, and PIOINT is the library. So what it shows that source physical file, this is one physical file of type source, and all other informations are mentioned here. What about DSP-FFD on this? Insert DSP-FFD. This will tell us the fields of the source physical file. So we mentioned that it has source sequence, source date, and source data. So 6 length is occupied by the source sequence, 6 length occupied source date, and another area is occupied by source data. So if you want to see this, suppose this is one order PF, source sequence, source data, source date, and so on. And as we mentioned that run query is to see the data of the source physical file or update data or STR-SQL. So can we run all of this in the source physical file? Let's see. Run query, source physical file. So it will show you. So basically the source physical file contains source data. So this is the source we created. If we query on this file, the system stores the source data inside the source physical file in this manner. And there are different source members. Okay. So suppose when we are running this run query on this source physical file, there is a parameter that calls member. Okay. By default, it is taking first one. So on the list, this is the first one. So it is taking first one. If I want to take this one, students data, we can give here member name. It will show you the source of that student data. Another important thing, we saw that we created this object, right? You can see the work object. The object was created, and there are some data as well. Okay, let's suppose for students, there are some data. This data is present there. Okay, and for order file also. So what if we delete this source from here? Will this delete the object we created? Because we need to understand that object is different and source is different. This is a source member, and this is object. We kept the same name. This is object of type star file. So this file also contains the data of order PF. It has some data. So let's delete this source member. Okay, option 4 is the shortcut to delete this one. If you take F4, it will show you remove member. So I'm deleting this order PF. The member is removed. Is the object still present? It is still present. So you need to understand that once we compile the source, there is no use of source after that for this PF, because it already compiled it. It created one object. It told the system that this object is of this particular structure. So the object is created. The data will be there, still there. Object will be still there. Even if we remove the source from the source physical file, the object is there. If we later want to modify that source in a specific manner, then we don't have the source available. We need to create it again. But everything, all operations you can perform on that object, physical file object, like previously, even if you delete the source physical file. Okay. After that, okay, I think we are almost 1 hour. Okay, so I'll just tell about this little bit, then we can maybe cover this on next session. Another concept is like physical file member. Okay, so on this table, we saw that this roll number, first name, last name, gender, date of birth, address, contact number. Suppose I want to implement this for different classes or different departments. My college has different departments, so I want to implement it in different departments. So in AC, electronics, there will be students in CSE. So one way is to add one column here that will say the department. It will have all the data of that particular every department. We can think of another way, like what if we create separate physical files? Suppose that will one physical file will contain the EC data, one will computer science data, one is information technology data. So that will be maintaining three separate physical files. We have one concept here that can ease that. So the concept is to add different members. So in a same physical file, we can have multiple members that will share the same structure of that physical file. Same structure means this structure. Suppose student PF, student, this structure. Different members will share the same structure, but the data will be different in different members. So for EC, this will be the data. For CSE, this will be the data. For IT, this will be the data. So this concept is called multi-member physical file. So we can create it as we are way over the time. Okay, we have 1 hour is completed. So this topic maybe we can explain the next session. So we can stop the session here, and if anyone has any question, you can feel free to ask. Okay, someone has asked that why we are using record field into a source section. Okay, so the record field using record, I think you are asking about this part, record format, this will R. Okay, so this tells the system that this is a record format. It has some multiple uses. Okay, we'll learn it later, but without telling this that this is a record format, it contains these fields. So it can, there are some uses of it, like it can refer to another record format. Suppose you are creating one physical file and you want to use the existing structure, that time it comes into use, or you are retrieving the record, that time it comes into use, like record format. So this is mandatory field. It is just we are naming this structure with this name, student FR. That's why this record is needed. Okay. Okay. One. Okay. Just as is the difference. Okay. What is the difference between S zone decimal, P fraction decimal, and S zone decimal, P? Okay. So S zone decimal and P zone. That means how the system stores the data. Okay. So packed means it will not contain that length of data. Suppose we are giving 5.2 in S2. So the system in the backend, okay, the example was here, I guess. I'll give you one live example here. Okay, so suppose this one I am given here 6s0. Let's see for the students what is the length it's stored in the system. DSPFFD we are giving students. So you can see roll number is storing 6 length and it is starting from buffer position 1 to 7. So inside my system, the record is stored in this manner, like this in a single row. So it has allocated 6 length. What if I mention here, I change it to having 6p0. Let's see what happens. Packed decimal. File, we compile it. And if we check the DSPFFD of students, you can see here it is storing only 4 length. So it is not storing, previously it was storing 6 length, it was allocating 6 length to that particular field, but inside my system it can allocate 4 length only to accumulate that 6 length data. That's why it is called packed. It is like zipping the data. Okay, any other question related to the session? Okay, how to make multi-member physical file? Yeah, we'll consider this in next session as time is over for today. Multi-member physical file, we can create it. So we can create it using this concept called add pfm, or there is a copy f option. So we'll run example in the next session of that. Okay, if we delete, what is the numeric code? Okay, numeric code. I'm not sure the question. Okay, numeric field, if we mention, if we delete the pf by using work object command, what is the process of retrieve that pf? Okay, work object option, if you delete that pf, that object is deleted. Using for option, if you delete the pf, the data is lost. So you can see if we delete that, that will be removed totally. So sometimes our PA for physical valid contains, I showed the example of like 3 or 4 students. Suppose in case of a e-commerce website, there are millions of records. So deleting is given restricted, like, or not all user can delete that PF. If you delete the PF, you are deleting the object. Okay, any other questions? Okay, VS Code, I'm getting an error while compiling. Okay. Yeah, we'll cover this later. Okay, joining two files will be, this topic will be covered in next session. Okay, as it is shared.
So, guys, we almost running more than 1 hours, and we almost answered all questions, open questions. So, thanks for today joining, and for the more details, you can visit to our PIO YouTube channels. Okay, and if you have any query, just ping into that YouTube channel. Okay, thanks for the joining today.
Yeah, thanks.
Bye.
Bye.